Metabolic Energy System Training. Chapter 5, Part 1. Metabolic Energy System Training. Chapter 5, Part 1. Learning Objectives. Upon completion of this chapter, you will be able to differentiate between aerobic and anaerobic energy systems. Describe the importance of the role of the metabolic energy system training in improving sports performance. Identify heart rate formulas and heart rate training zones for use in metabolic energy system training. Describe methods for developing metabolic energy system training plans. Page 194, Introduction, Chapter 5, Metabolic Energy System Training. Sports performance professionals must be creative in developing new cardiovascular training experiences. The term athlete as it is used here encompasses people at all competitive levels, including high school or college students, professional level athletes, as well as recreational athletes who compete in weekend races or local leagues. All athletes need goals and proper training guidelines to assure continued growth. Personalized cardio programs will go a long way towards achieving specific goals. To have a complete cardio program, one must first assess the athlete, then create a program with specific goals while applying a measurement tool, such as heart rate or watts, to measure the athlete's progress. Metabolic energy system training concepts. Of the various components that comprise an athlete's total physical fitness program, cardiorespiratory endurance is probably the most misunderstood and underrated. The athlete often fails to understand why building an aerobic base is such an important part of a complete training program. Without a proper base, performance may decrease over time, which could lead to underperformance and possible injury. Many people incorrectly assume that metabolic energy system training is synonymous with aerobic training. This misunderstanding can delay or even prevent athletes from realizing success from a program designed to meet goals specific to their sports. Metabolic energy system training is more than just training the aerobic energy system. To meet these goals, both aerobic and anaerobic systems must be trained. This is especially true for athletes who must constantly tap into top-end anaerobic energy systems while maximizing performance and minimizing fatigue, such as tennis players late in the match. This would be impossible if only the aerobic energy system was trained. This would be impossible if only the aerobics energy system was trained. Review of energy systems. The body cannot survive, much less perform physical work, without energy. This energy is provided in the form of adenosine triphosphate. ATP is produced by the body from the foods it consumes. ATP is produced aerobically with oxygen and anaerobic without oxygen. ATP is produced aerobically with oxygen and anaerobically without oxygen. Of these two methods, the most efficient far is the aerobic system. The normal heart beats approximately 70 beats per minute at rest. The heart of a well-trained aerobic athlete can beat as few as 40 times a minute. This kind of heart conserves energy and can supply oxygen-rich blood to the rest of the body with up to half the effort. So it's pushing more because it's pumping less amount of times. Page 195. Aerobic training stimulates the heart to adapt by becoming larger and stronger through exercise to supply the body's ever-increasing demand for oxygen. The heart becomes a more efficient pump by pumping more blood per beat, meaning it does not need to beat as often to supply the same amount of oxygen. Aerobic energy production requires a constant and adequate supply of oxygen. Aerobic energy production requires a constant and adequate supply of oxygen. The respiratory system begins with the lungs, which bring oxygen from the air across the alveolar membrane. The respiratory system begins with lungs, which bring oxygen from the air across the alveolar membrane and into the blood to be carried by hemoglobin. This process is called pulmonary ventilation. The movement of oxygen and carbon dioxide into and out of the circulatory system takes place through diffusion. Pulmonary ventilation definition: the process which brings oxygen from the air across the alveolar membrane and into the blood to be carried by the hemoglobin. With each contraction, the heart pumps blood out of the left ventricle into the aorta, distending it and creating pressure, systolic. Distending it and creating pressure, systolic, on the vascular wall. During the relaxation phase of the cardiac cycle between beats, the blood pressure, diastolic, in the arterial wall system declines. During relaxation phase of the cardiac cycle between beats, the blood pressure, diastolic, in the arterial system declines. The amount of blood the heart pumps per minute is the cardiac output. The amount of blood the heart pumps per minute is called the cardiac output. This number is determined by multiplying the heart rate by the stroke volume. The amount of blood pumped with each contraction of the ventricles. Cardiac output and oxygen consumption are linearly related. As cardiac output increases, oxygen consumption will increase as well. Cardiac output and oxygen consumption are linearly related. As cardiac output increases, oxygen consumption will increase as well. The body's oxygen requirement at rest or in any steady state is a constant. A greater stroke volume means the heart beats less often. During exercise, the stroke volume increases in proportion to the intensity of exercise to about 40% of capacity, at which point the stroke volume starts to plateau. Thus, beyond this intensity, increases in cardiac output are due to the increased heart rate. During exercise, the stroke volume increases in proportion to the intensity of exercise to about 40% of capacity, at which point the stroke volume starts to plateau. Thus, beyond this intensity, increases in cardiac output are due to the increased heart rate. With training, the response of stroke volume to increasing increasing intensity is the same, but happens at a higher level due to the increased pumping power of the heart. The heart rate response to increasing intensity is a linear relationship, and after training, the maximal heart rate is unchanged or slightly lower. The main reason maximal cardiac output and thus oxygen consumption is improved with training is in large part due to the increase in stroke volume. What is stroke volume? Stroke volume is the amount of blood pumped with each contraction of the ventricles. The main reason maximal cardiac output and thus oxygen consumption is improved with training is in large part due to increased stroke volume. Stroke volume is the amount of blood pumped with each contraction of the ventricle. This change in stroke volume is one of the main central cardiovascular adaptations to training. Heart rate can change from rest to maximum by around a factor of 3. 3 by a factor of 3, from 60 to 180 beats per minute. While the stroke volume changes by only a factor of 1.7, from 70 to 120. While increasing heart rate is a main factor in increasing cardiac output, if training increases the stroke volume by even a small amount, any increase in heart rate will show substantial changes in cardiac output. Resting cardiac output is typically 6 liters a minute at rest and about 20 to 25 liters a minute during maximum exercise. But for the aerobic elite, cross-country skiers, rowers, cyclists, it may be over 40 liters a minute. See, this is cool. Resting cardiac output is typically around 6 liters a minute at rest and about 20 to 25 liters a minute during maximum exercise. But for the aerobic elite, it goes all the way up to 40 liters a minute during exercise. The chemical reactions that transform energy in the cells of the body are collectively known as metabolism. It has been estimated that if one could put all the ATP of the body into a glass, that glass might be between a shot glass and a small juice glass. With such a small amount of ATP at any time, the body must continually produce ATP. For the purpose here, metabolism is understood to supply the energy needed to carry out the mechanical work of muscular contraction across the intensity spectrum. Aerobic system. Chapter 5. Aerobic system. Page 196. Aerobic exercise requires the body to take oxygen from the atmosphere, deliver it to the lungs, transfer it into the blood, and pump it to the working muscles where it is used to oxidize carbohydrates and fats in order to produce ATP. The energy pathway is often termed the oxidative system and involves several body systems, including respiratory, cardiovascular, muscular, and endocrine systems.